Hi, hello, and welcome to BK'sTechStack. I am BK. Today, we are going to learn about defining Agentic AI architecture.
Let's start by understanding what Agentic AI architecture truly is. It's not just a collection of code, but a structured arrangement of components. Think of it as the blueprint for an intelligent system. It maps out how different parts communicate, manage data, and maintain control. By defining these interactions early, we ensure that our AI can remain modular, scalable, and highly effective at performing complex tasks.
When designing your system, you must choose the right pattern. Single-agent patterns are excellent for focused, well-defined tasks where a centralized control system is sufficient. Conversely, multi-agent patterns shine in complex, distributed enterprise environments. Here, multiple specialized agents collaborate, making it ideal for tasks that require parallel processing and dynamic problem-solving.
At the heart of every agent is the sense, plan, act cycle. First, the perception module gathers data. Next, the cognitive module processes this to create a plan. Then, the action module performs the task. Finally, feedback closes the loop. This iterative process is crucial for creating intelligent, self-correcting agents that can adapt to their surroundings.
Let's look at the implementation. Here, we define a perception module class. Its primary role is to act as the eyes of your AI. It takes raw, unstructured input from the environment, strips away the noise, and converts it into a clean, structured dictionary format. This structured data is then ready to be passed to the brain of the agent.
Next is the cognitive module. This is the decision engine. It reads the structured output from your perception layer and applies logic to it. In this simple example, the module evaluates if an input is urgent. If it is, it triggers an alert. Otherwise, it logs the event. This allows the agent to exercise basic judgment based on the environment's state.
Once the cognitive module decides on an action, the action module takes over. This class is responsible for the actual execution. It interacts with the outside world, whether that's calling an external API, modifying a database, or sending a command to a physical device. It converts the abstract intention of the agent into a concrete, quantifiable result. To build more advanced systems, we use frameworks like LangGraph. Run these installation commands in your terminal to set up the necessary environment. These tools provide the backbone for orchestration, allowing you to manage state, memory, and tool usage across multiple agents efficiently. It's the first step toward building enterprise-grade agentic platforms.
Let's explore the reflection pattern. This is a game changer. Instead of blindly executing, an agent is programmed to pause and review its own output. It evaluates its reasoning. If an error is identified, it modifies its strategy before moving forward. This self-examination leads to far greater flexibility and higher accuracy in complex environments. Now consider the tool use pattern. LLMs are powerful, but they have knowledge cutoffs. By giving them access to external tools, like web search engines, calculators, or specific APIs, we break those constraints. The agent identifies what it doesn't know, queries a tool, receives the data, and uses that new information to generate a much more accurate, helpful response.
For truly difficult tasks, we use the planning pattern. Instead of attempting a massive goal all at once, the agent creates a breakdown. It identifies the smaller steps needed to reach the objective and orders them logically. If one substep fails, a well-designed planner can trigger a contingency or a backup plan, making the whole system much more resilient.
Two popular patterns are react and rewoo. React is iterative. The agent thinks, then acts, then thinks again based on what happened. It's very dynamic. Rewoo takes a different approach by separating the plan from the execution. It generates a full plan first, then executes the tool calls. This is often faster and less prone to looping, but less flexible than React.
When moving to a multi-agent system, the benefits are significant. You gain true parallel processing power. Because tasks are distributed among specialists, the system solves problems faster. Plus, the redundancy is a huge win for reliability. If one agent crashes, the others can pick up the slack. It's essentially building a high-performance team within your software stack. When implementing these architectures, keep 3 design principles in mind. First, goal alignment.
Don't let your AI get distracted by tasks that don't serve your business. Second, always maintain a human in the loop. Automated systems need guardrails. Third, prioritize continuous learning so your agents actually get better at their jobs as they encounter new, real-world data.